Welcome back. This video is about braking of DC motors. The main theme of braking is to stop the motion or to oppose the motion. In braking, the motor works as a generator developing a negative torque which opposes the motion. During the operation of electrical drives, it is often necessary to stop the motor quickly and also reverse it. In this situation, we are in need of braking. If the supply to a motor is disconnected, it stops after some time when all its kinetic energy is given to the load. However, when the motor is to be stopped quickly, the braking torque is applied to it. There are basically three types of electric braking in DC motor. The first one is regenerative braking. This type of braking is possible in the case of drive motors where the speed can go beyond no load speed or the terminal voltage can be momentarily decreased. In regenerative braking, generated energy is supplied to the source under two conditions, that is E is greater than V and IA is negative. The speed and the armature current are related by these two equations, that is N is equal to V divided by Ke phi minus IaRa divided by Ke phi the whole square, and the armature current is V minus back EMF E divided by Ra. During regenerative braking, Ia is negative because E is greater than V. The torque developed is given by Tb is equal to Kt phi Ia. Now, the speed of the DC motor becomes V divided by Ke phi plus Tb Ra divided by Kt Ke phi the whole square. So, the speed of the motor extends into the second quadrant where the torque is negative. It passes through the no-load speed point with the same slope as in the first quadrant, that is forward motoring. Hence, the forward braking is achieved. So, the main point in regenerative braking is whenever E is greater than V, Ia is negative and hence the torque is also negative. Now, the motor characteristics moves to the second quadrant, that is forward braking. Next, we have dynamic braking. In regenerative braking, it is impossible for the motor speed to be greater than the no-load speed. Regenerative braking is not possible if it is impossible for the motor speed to be greater than the no-load speed, or if the armature voltage is constant and cannot be varied smoothly. Dynamic braking is employed in such cases where the kinetic energy of the rotating path is dissipated in an external resistance. The dynamic braking connection is as shown in the figure. Initially, the motor operates at its rated voltage V. When braking is required, the armature is switched on to an external resistance Re. The field remains connected to the supply with full excitation, and the induced voltage in the armature has the same polarity. The armature current reverses and flows in the direction opposite to the current during the motoring action, developing the the braking torque. This kind of braking is effective and the motor stops very fast if the field is available at its full value, for which reason it is separately excited. Then finally we have plugging, which is also called as counter current braking. This braking is used for quick stopping of motor, and it is also used for reversing drives requiring a short time of reversal. In cranes and hoists, the motor is switched on to raise the load of the instant when the associated gearing operates in the direction to lower the load. For plugging, the supply voltage of the motor is reversed so that it assists the back EMF in forcing the armature current in the reverse direction as shown here. The resistance R brake is also connected in series with the armature to limit the current. So, whenever the plugging is required, The supply voltage is reversed so as to reverse the armature current, and the armature is also connected with a series resistance to limit the current. Thank you all for watching.